Welcome, my friends. Let us begin. So in the first video was pretty long, and I'm hoping that we can begin to make him a little bit more faster. I'll go a little quicker, but I hope that foundational piece is there for you. And kind of what I want to hit on today is some of the really cool stuff here, which is there's a starting value. So look here, a student wanted to save money. She's going to put 3/4 in a container every single day, very similar to the problem in the first video, but what's different is she currently has 14 quarters in her container. So if you think of some container here, she already has 14 of these: 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, so it's already 14 quarters, and we want to find out really how much money she will have after 120 days, right? How much quarters will she have after 120 days? Well, we want to be able to do this without having to make a table and go all the way down blah 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 to 120. There's got to be some kind of shortcut. So what do? Well, before she starts putting money into the container, we ask ourselves, how much did she start with? Well, we drew this picture. She started with 14. So let's write 14 here. Okay, and what's going to happen next? Well, every day she's going to add 3/4. So when one day passes by, well, we add 3. 14 plus 3 is 17. Okay, and then as another day passes by, we add another 3/4, which is 20. Then another 3 days passes by, and then we'll add more, another 3, and then boom, 26, so forth and so forth. So here it is. Okay, well, here's the problem. We can't just do, well, we're just adding 3 every time. And we can't just do 3 times 26, right? Because this is not taking into account our starting. How much did she start with here? Well, she started with 14. So we want to write some equation. Well, let's go ahead and at least label a few things. So I'll write here that x is equal to the number of days. Okay, why does that make sense? Well, over here, this is saying as one, when one day passes by, second day, the third day, the fourth day, the 26th day. Okay, and y, well, y is representing the number of quarters. Okay, if we wanted to, we could have totally changed the letters. It doesn't matter. So we have y is equal to, okay, well, how much are we starting with? Well, we're starting with 14. So we'll do 14 plus, and then how much are we always going to add by? Well, we're always going to add by 3. And so we get 3 here. Okay. Well, are we just going to add 3 once? Well, no. It depends on how, if I told you day 4, how many times do you need to add 3 to get to day 4? Well, you need to add it 4 times, right? So we would do 3 times 4 because we need 4 copies of the 3. So turns out we can just label this as 3 times x. Okay, and so our equation for this will be y equals 14 plus 3x. Okay. Why? Well, the x represents the number of days. So for example, if I plug in 3 into here, well, how many times do I need to add 3 to get to the third day? Well, 1 2 3. It's right there, right? So plug in 3. We get 14 plus 3 times 3. We first have to, well, we first need to multiply these, right? We need to take care of this first before we do anything with the addition. So 14 plus 9. Well, what's 14 plus 9? Well, my friends, we get 23. And that's exactly what we got when we filled out the table. All right. Now, you might be accustomed, though, to see things like 3x plus 14, right? And the 14 is our starting value because it doesn't have an x or our y-intercept, which we're going to get to later. And it doesn't matter. You can rewrite this like this, however you want. It doesn't matter because what's 2 plus 3 or 3 plus 2? Well, 2 plus 3 is 5, 3 plus 2 is 5. So you see, it doesn't really matter which way we write the equation. And we're going to get a little bit more practice on that. So let's go take a look at this other example. Similar to the problem we did before. These are all similar to what we did before in the first video, but just an extra addition to it. So every month, so same situation, the bank, if you don't have a minimum amount in your bank account, they'll charge you a fee. In this case, we'll say it's a $20 fee. A friend of yours took out all the money to go to the Kendrick Lamar concert and didn't know about this. Every month, he will get charged $20. He currently has $200 in his account. So I should maybe change that. The friend didn't take all the money out. It just took some of the money out. And he's starting with $200. Okay. Now, if he only has $200 and let's say and that didn't meet the minimum requirement, well, they're going to charge them $20 to keep the account active. Well, first things first, well, this shouldn't be 0. Let me write this. We could write this as X and Y, or again, the letters really don't matter. I'll put X and Y, but I'll show you that we could change them if we want to be something completely else. So how much money does he currently have in his bank account? Well, he's starting with 200. So when it's X is 0, we start with 200. Okay. What happens after a month goes by? Notice that this problem is talking about months. So I might come up here and label X to be number of months. Okay. And I'll label Y to be his money in the bank. Okay. Well, what happens after the first month? Well, after the first month, they're going to take $20 out the account. So he's going to be left with 180, right? So 180, right? We're going to subtract 20. And if I do this over and over, right? After the second month, what's going to happen? Well, they're going to subtract another 20. So he'll be left with 160. And then 160 minus 20 is 140. And then 140 minus 20 is 120. You see, we're just subtracting 20 every month as every month goes by. And we want to know, well, how much will this individual have in his bank after 24 months, 2 years, if that money was just left there and he had no idea? Well, we just write this out. We know Y represents the total money in the bank. Okay, Y equals, how much did he start with? Well, he started with 200. And then what's going to happen? What's our constant rate of change? What's happening here every single time? Well, my friends, we're subtracting by 20. So we're going to be we're decreasing by 20 every single month. So since X represents a number of month, well, negative 20 times X. There it is. And then again, multiplication is a shortcut for addition or subtraction. So if you think about it, let's go to number 3 here. How many times after 3 months did we have to subtract 20 to get to 3? Well, 3 times. How many times do we need to subtract 20 to get to 2? Well, twice. So if we use our equation and plug it in, we'll get 200 minus 20 times 2. Let's do that, right? Well, to get to the second month, we had to subtract twice. That makes sense, right? There's 2 copies of the negative 20, so we get Y is equal to 200. We do this first, just like in the table, you would subtract first, and this is negative 40, and we get Y is equal to 160, which is exactly how much money is left with right over here, okay? And pretty much what I wanted to show you was you could let X and Y be something totally different. Instead of having X be number of months, you could just say M, because that means months. This means the number of months, right? You could have, since we're talking about money in quarters, dollars, you could write dollars and be dollars. So if you wanted to write the equation, write dollars in bank. We could do D is equal to, we're starting off, right? How much the dollars in the bank? Well, we're starting off with 200 and we're going to subtract 20 every month. So we'll multiply it by M. This is another way to write an equation with different variables. And it really don't matter as long as you just define them to be what you want them to be. Okay. All right, let's check out this next one. Let me just see how much time we're at, because I do want to move a little quicker. Okay, we're about 8 minutes. We'll slowly wrap it up. So Mr. AC put a hoodie and started rapping in the hallway, you know, because I'm filthy like that. At first, there was only 2 students there. As the word was spreading, we had a new student show up every minute. The hallway can hold 100 students maximum. Create an equation. So let's think about this for a minute. If I wanted to create a table, which I could always do right away first, all right, again, I could use X, or I could use something like S for the number of students. It doesn't really matter. It's whatever makes sense to you. And I'll put Y. So let's say X is equal to, well, what's happening? What's the time? Is it every month? Oh, look, it's every minute. Okay, so let X be, you know what? Let's change it, because I do want to just show you how it works. Okay, let's let T be equal to T for time. So let's be every minute. Okay. And what's happening after every minute? Well, new students are showing up. So number of students. So we'll put T here for every minute that passes by, and S over here for the number of students. Well, before people show up, when time 0, how many students are there initially? Well, there's 2 students there. So 2 students. Okay. And then after 1 minute, what's going to happen? A new student shows up. So if there's 2, how many will it be? Well, 3. And now you can see, oh, well, after another minute, there'll be 4 and 5. Okay. Well, how can we write an equation for this? Well, we can do, okay, the number of students is equal to, well, how much did we start with? How many students? We started with 2 students plus how much are we changing by? Well, we're always adding a new student. So we could do 1 times t, right? T represents the number of minutes here. So we go over here and we get 2 plus 1 times t. Okay. Now, how many students showed up after 10 minutes? We'll take the 10 minutes and plug it in. Take the 10 minutes and we'll plug it into here. So we'll get the number of students is equal to 2 plus 1 times 10. Well, what's 1 times 10? We get 10. What's 2 plus 10? We get 12. So the number of students is 12. So 12 students. Okay. Well, how long will it take until the hallway reaches its maximum of 100 students? Well, don't worry about that for now. We will get to that later, but that's just for you to know. So here in the basic sense, here's how we can set up an equation if we wanted to. A car rental company charges customers an initial charge plus a daily charge to rent cars. So if you're going to go rent a car, you need to put like a down payment. And after you put that down payment, that initial charge, they charge you like monthly or every day. So the initial charge is $5 and the daily charge is $20. So you first have to just drop $5 and then afterwards you have to pay $20 daily every day. How much will it cost if he has it for 5 days? Well, we can make a table and I can use anything. I guess I'll go back to X and Y. Okay. Before a day passes by, how much do you have to initially put down? Well, it says initial is 5. So this is 5. Okay. And if a day passes by, how much are you going to have to put down? Well, 20, $20. So what's 5 plus 20? Well, 25, right? Because now this is how much it's going to total cost you. Okay. After a second day passes by, how much is it going to cost in total? Well, after the second day, well, we added 20 here. We'll just add 20 here. 25 plus 20 is 45. And we can just repeat this over and over until we get all the way to the day number 5. Just keep adding 20. 4, 5, 6, 65. 65 plus 20 is 85 plus 20 is 9, 10, 105. Okay, but we can write an equation for this. We'll do y is equal to, how much did it initially charge? Well, $5 plus, okay, and how much are we changing by? Well, the daily charge is 20. So plus 20 times X. And that makes sense, right? Imagine if you take the 5 and plug it into here. Y is equal to 5 plus 20 times 5. Y is equal to 5 plus 20 times 5 is 100, and we get y is equal to 105. And that's it, my friends. That kind of concludes the video. Hopefully that makes sense. Again, maybe to make a little more sense, again, since X is over here on the left hand side, this always generally represents time. Well, in this case, this was a daily charge, daily. So this is days. Okay, so number of days, and y is equal to, well, the total charge of renting the car. And that pretty much it, my friends. And that'll help us at least be able to hopefully understand how you can take a story problem and translate it to a situation like that. All right, my friends, take care.